features, there's a little bit more advanced points and line projection that we have to do. And we'll be introducing the concept of auxiliary planes. Auxiliary planes are now additional planes other than the horizontal plane and vertical plane, which we have been talking about to generate the top view and front view so far. Okay. Why do we need additional planes, which are calling as auxiliary planes? Because if there are some faces of the object, the faces of course contain lines, lines contain points. If you have such faces which are not parallel to either the horizontal plane or vertical plane, then the projection of such inclined faces on horizontal plane or vertical plane are not true projections, in the sense that the length of the line or the area of a face will not be the same as the real area. So let's go back on that. So we're talking about horizontal plane and vertical plane. We will now introduce a third one, which is perpendicular to both the planes, which we'll call it as profile plane. All these are perpendicular to each other, and that therefore they're called as principal planes. And what are principal views? We talked about front view and top view so far. We will also talk about side view. All these three views on the principal planes are called as principal views. That's also straightforward. But now we are getting into it something more, which is in addition to these three planes and these three views, which are all perpendicular to each other, we are now introducing the concept of auxiliary planes or additional planes. We'll call it as auxiliary planes, which need not be parallel or perpendicular to any of the three things I talked about before, the principal planes. Now, why do we need that? I just mentioned earlier, a length of a line which is inclined to one of the principal planes, its projection is shorter than the actual length of the plane. But if your projection plane is parallel to the line, then the length of the line is exactly same, the true length and the projected length are exactly same. So a plane in which the true length is projected length is same as the true length, it will be an auxiliary plane of usefulness in a context like this. So we can get true length of a line. Similarly, you remember that angle of a line was different, the true angle and the projected angle. So now we can start getting the true inclination of a line, for example. We can also do things like distance between two lines, which are not parallel and which are both inclined also. And eventually, when we extend it to planes, we can start getting the true shape of a planar object or planar face. So now let's go forward onto the auxiliary planes. For the sake of simplicity, we'll just talk about two kinds of auxiliary planes. It can be infinite numbers, but we'll talk about only two kinds of auxiliary planes. One is an auxiliary vertical plane, which is similar to vertical plane, but it is no longer, but it is inclined to the normal or principal vertical. Principal vertical plane is perpendicular to horizontal plane. Auxiliary vertical plane is also perpendicular to the horizontal plane. In that sense, auxiliary vertical plane and vertical plane both have the same property. Both of them are perpendicular to the horizontal plane. Okay, but the auxiliary vertical plane is now inclined to the principal vertical plane or the normal vertical plane, which we have been talking about so far. So that is one kind of a auxiliary plane, auxiliary vertical plane. We can similar to that, we can also have a auxiliary horizontal plane, but it is not called auxiliary horizontal plane, it's called auxiliary inclined. Just convention, because when we look at a plane, when we see inclined plane, usually it is something inclined from the horizontal, right? So we call it as auxiliary inclined. Auxiliary horizontal plane doesn't make sense because horizontal plane is supposed to be horizontal. So people are calling it as auxiliary inclined plane, which is a deviation of the horizontal plane. In what way it is a deviation? It is nothing but in a plane which is inclined to the horizontal plane, but continues to be perpendicular to the vertical plane. Horizontal plane is vertical, horizontal plane is perpendicular to vertical plane, and auxiliary inclined plane is also vertical. Keep saying sorry. And auxiliary inclined plane is also perpendicular to the vertical plane. So in the sense, both of them are similar. Now we start looking at projection of points on the auxiliary planes. Let's first take the auxiliary vertical plane. And just one important point, if you keep in mind, many things will be very easy to understand and also draw in the next lab class, okay? Which is because vertical plane and auxiliary vertical plane are both perpendicular to the horizontal plane. One nice thing that can happen is if you look at a point A and its projection on the horizontal plane is A, projection on the vertical plane is A dash, that we already remember from the last class. Okay, so the height of the point A above the horizontal plane, the height of point A from horizontal plane has to be same. A projection of this thing has to be same in both vertical plane and horizontal and auxiliary vertical plane, in the sense that the height of point A from the horizontal plane as projected in any vertical plane has to be same. In other words, what I'm trying to say is your OA dash and O1 A1 dash distance has to be same. Both represent the height of point A above the horizontal. Now just also look at the notations carefully. You know notation A is for your horizontal plane and A dash vertical plane. But because now we're talking about the auxiliary vertical plane, okay, the A dash now becomes A1 dash. Why 1? Because this is the first auxiliary plane. Suppose you have multiple auxiliary planes, you may call it as A1 dash, A2 dash, A3 dash, and so on. That's a convenience in case you have multiple planes. So how do we draw the projections of the point A on the auxiliary vertical plane? First, let us do the normal vertical plane. So you draw your line XY, and you draw a line, a vertical line perpendicular to the XY plane.
Hello, Saurabh.
And you map your point A.
Could you please just pause the video? Yeah. Actually, there is some problem because some another meeting has started. We are just trying to figure it out. Yeah, we'll just pause it over here. Just give us 2-3 minutes, okay? You can unshare, yeah. Sorry, you can unshare, yeah. Students, yeah, please give us 2-3 minutes, okay? We are just trying to figure it out. We will then resume the class, okay?
Prabhat. Hello.
Yes, Samrat.
Hello, Shubham. Shubham Jaydeep, are you here? Guys, do you also see two meets running parallelly? Because we cannot see another meet, other student having. Can someone respond?
Yes, Samrat, even I can't see the other meeting, but I don't. Somebody may have ended that because you can see we have 105 attendees.
Shubham, Jaydeep, Wagmare, Suyash.
I think I think the problem is that actually sometimes it happens with teams that the link is the same, but when we join the meeting via calendar, so the although the meeting link is the same, but then also the people enter some another meeting with less number of people, because it has happened quite a lot of times in our in for us, like for example in physics also it happened last time. So that's
Okay,
the
okay.
problem.
So
Okay,
from
so
next time, can you